Okay, so now that you understand what inequalities are, and you understand how to put the inequality on a number line, and how to translate that number line into an interval, so basically abbreviating it to interval notation, now we're going to work on solving linear inequalities. And it's going to be a shorter video. Why? Well, this is great. Solving inequalities is exactly the same thing as solving linear equations. You do the same stuff. You simplify both sides. You combine some like terms. You get rid of your smaller variable by addition subtraction. You get rid of your constant by addition subtraction. And the last step is you divide to get rid of the coefficient. That all works exactly the same with one exception. And it's just a little add-on basically. Solving linear equalities is just like solving linear equations with one exception. If you multiply or divide, so addition subtraction has nothing to do with this. If you multiply or divide by a negative, not get a negative. I don't care about getting a negative. I don't care about addition subtraction. I don't care about multiplication. If I'm not dividing by a negative, even though I get a negative on the other side, if I multiply or divide by a negative number, you must reverse the inequality. What that means is inequalities that start out like this, you have to change them to this, and inequalities that start out like this, you have to change to this. You reverse it. You flip it around. Less than becomes greater than becomes less than. Less than or equal to becomes greater than equal to, greater than equal to becomes less than or equal to. That's what I mean by reversing inequality. The only time you ever do this, when? When's the only time you ever have to do this? It's not adding, subtracting. It doesn't even have to do with a negative number on the other side. It has to do with when you're dividing on the last step. Remember, last step. That's when you divide. When you divide on the last step, by a negative is when you flip the inequality. Never before that with the way that I've taught you how to do linear equations. So we're going to practice that. It's going to be quicker because you have all the tools. All I've got to get you to do in this video is understand that when you're dividing in the last step, if you divide by a negative, flip the inequality. We shouldn't ever really be multiplying by negatives. I'll show you why when we get to some fractions in the next video. But really, it's just about dividing by a negative. If you see that, flip the inequality. Other than that, you're good. A couple of things to keep in mind when we're going through this. Number one, we really do always want to end with our variable on the left-hand side of our inequality. Do you remember why? Do you remember why that was important in the last video? If you have your variable on the left-hand side, your inequality points to the direction that you're supposed to graph. Whether it's greater than, go to the right, less than, you go to the left. That only works if your variable is on the left-hand side. So that's what we're trying to go. So keep that in mind. Also keep in mind that if you have the little equals, less than or equal to, greater than equal to, we use brackets. And if we have less than or greater than, we use parentheses. So we're going to be solving these. We're going to go right down to our number lines, and then we're going to do interval notation. So it's several steps, but all of them you really do know. The only thing that's new in this whole video is that right there. So if you can keep that in mind, you're going to be golden. Let's start with the first one. Let's notice that if this were an equation, if you were trying to solve this for your variable, there's still two sides. You got a left side, you got a right side. Your variable is on the left-hand side. It's x. It's not isolated. We're trying to get this guy by itself. You can still draw the line if you really want to. You don't have to. But what you do have to do is realize that whatever you do to the left side, you have to do to the right side, just like on equations. So in isolating our variable, we're using the exact same techniques. Simplify first, distribute, combine like terms, get rid of fractions. Then get rid of one of the smaller variables. If you have two variables, get rid of the smaller one by addition or subtraction. Then get rid of your constant by addition or subtraction. The last step is division. The last step is the only time when you could change your inequality around if you follow the way that I'm teaching you. So let's look at this. How do I get x by itself? Same thing I always will. It's simplified on both sides. There's no like terms on either side. I look for two variables, I don't have any. Then I look for a constant. I have a constant connected to my variable. Let's subtract it. Hey, x plus 6 minus 6. Remember, with addition and subtraction, we're getting zeros. We're trying to get zeros. X plus 0 gives you x. On the right-hand side, 3 plus negative 6, or 3 minus 6 is negative 3. Now, don't miss this, okay? Get this. I don't care that I got a negative number. I am not going to switch that inequality around. The only time you ever switch it It's not when you subtract, it's not even when you get a negative, it's only when you have divided. In this problem, we don't even have to divide. There is no way we should be switching or reversing that inequality. That's x is less than negative 3. Done. Treat these like equations. The only thing that is different is that we always want our variable on the left-hand side, just like this. And we always reverse the inequality when we divide by a negative. If you multiply by a negative also, but that will rarely happen. Follow my way, it'll never happen. So when you divide by a negative, you reverse that. That's the only two differences. Now, we do have to show our solutions differently. As in the last video, hey, do you recognize that? It's really similar to the stuff that we ended with in the last video. That's because this is one of the ways we write our solutions. We also write our solutions on number lines. So solving inequalities is a little bit more involved than solving equations because you need an ending form. Okay, you need your variable on the left-hand side so that you can graph it better, and you need your graph so that you can make your integral notation. And you have to worry about dividing by negative. That's it. So let's make our number line. Here's negative 3. What we learned in the last video, this is awesome, is that if your variable's on the left-hand side over here, it is, your inequality will literally show you the direction to graph because numbers that are less than negative 3 are always less, and numbers that are greater than negative 3 are always right. So in this case, we go, okay, we want numbers less than negative 3. We want numbers to the left of that. Notice how this is kind of like an arrow pointing to the left. Would this work if my x was on the right-hand side? No. This is why we have to have these in a certain format to follow this technique. Okay? Do you have to do it my way? No, I guess not. Well, my way makes it pretty easy. So put your variable on the left-hand side all the time, and you will always follow your inequality to graph. Now, what do you think? Should we use parentheses or brackets here? Think back to whether or not this number is included or not. That less than or that greater than, when you see that, says that you're not including the number itself. You're getting right up to it, but you can't include it. Do you remember how to represent that? Is it the bracket or is it the parentheses? Here's another question. Is it the closed circle or the open circle, if you have to use that? In this case, when we're strictly less than a number, we don't get to include it. Now, the last thing is the abbreviated number line called an interval. Start where your interval starts. End where your interval ends, but keep in mind, you must go from left to right. So your interval ends. I know the arrow's pointing that way, I get it, but we always read from left to right no matter what. Your interval ends at negative 3. That means it starts way that way. It starts at like negative infinity. It ends at negative 3, and we use our parentheses. Parentheses always for infinities, and then parentheses for negative 3 because it's not included in the solution set. This says that we're excluding the numbers that keep the two sides equal. That's why we exclude that 3. Negative 3.000001, fine, that's right there, but not negative 3 itself. Let's try the next one. Let's see if we can do this. So right now, I'm kind of pretending this is an equation. The two keys are, I want to keep my variable on the left. If I mess that up, that's okay. We can switch it at the very end. I want to keep my variable on the left if I can. And then I also want to divide by a negative and switch my sign if I have to. So if I have to divide by negative, I switch my sign, switch my inequality, reverse my inequality. Now, if this is a linear equation, if this were a linear equation, I'd have my variable on the left-hand side and it would be connected to a constant. I need to get rid of that constant. Do you remember when we have something like this? It looks really similar to linear equations, and if you've practiced enough, you know that in order to get rid of this 4, if something's connected by addition or subtraction, I need to use addition or subtraction to undo it. So I will be subtracting 4. If something's connected by addition or subtraction, we want zeros, because 0 plus or minus the variable gives me back the variable. When I'm dividing, I want ones. So I'm going to subtract 4, and I am for sure going to do this to both sides. The same techniques for linear equations work for linear inequalities. Watch what? 4 minus 4, that's 0. 0, oh, that's the big one. 0 minus x. Is it x, or is it negative x? That's the question. Well, if you did 0, 4 minus 4 is 0, minus x, 0 minus 5 would give you negative 5. 0 minus 2 would give you negative 2. 0 minus x is going to give you negative x. It is a huge, huge deal here that you don't forget that sign. I grade a lot of stuff, okay? A lot. And when I get down and I see this, it's like a knife to the heart. Okay, it just stabs me right there and I start crying. Because people, they understand the concept, but they do these little things that just hold you back, okay? Sign errors are the #1 math mistake. Like in all of mathematics, most of them, vast majority of them, are sign errors. So if you're going to make a sign error, don't do it on this type of problem. You're going to see why. It's going to completely jack up your inequality, completely jack up your interval. If you subtract 4 from 4, yeah, you get 0. But this sign, remember how the sign in front of a term is always associated with the term? It sticks with it. You have not got rid of that negative. You have to have that. Now, let me ask you a question. Did we divide by a negative yet? Well, no, we subtracted a number. That's not dividing. I don't have to change my inequality. I don't have to reverse it. I just do 7 minus 4 and I get 3. That's all you got to do. Treat this just like an equation. Don't mess your signs up. If you divide by a negative, then you reverse inequality. Now we're about to do that. You see, we can't end with negative x. We've got to end with positive x. And we know that there's a little 1, a little -1 right in front of the x. If we divide by -1, remember how with division you're trying to get ones, positive ones? -1 divided by -1 is positive 1. That's 1 times x gives you x. On the right side, 3 divided by -1 is -3. Now, I could not care less whether that number ends up as a negative or positive. That is not what I'm focusing on here. What I'm focusing on here is the last operation that we did. What we did is we divided, and we divided by a negative. Not that we got a negative, not that at all. Not that we subtracted and got a negative here. That we divided by -1. That's a negative number. As soon as you do that, your inequality must reverse. Less than becomes greater than becomes less than. So less than has to reverse and give us greater than. That's going to be the biggest mistake in inequalities. #1, sign errors, but #2, forgetting to do that. Or doing it too often. Like if you get a negative, flip it. Don't do that. Don't flip it. Don't do the flippy dippy unless you're dividing by a negative. That's the big key. Now, can you keep going? Could you tell me what numbers those are? Could you tell me what's represented? Well, this is awesome. Is our variable on the left-hand side? That's tremendous. Because if it is, all we've got to do is put the number that's given to us, that's -3, and graph in the direction our inequality says. Only if your variable's on the left. The numbers bigger than 3 are to the right of 3. That's why this works. It points to the right. And the numbers bigger than x, or bigger than -3, are the numbers to the right. How about this one? Should I include the -3 or not? Doesn't look like it has an equals. So that's excluding the values that make the two sides equal. To show that, we say we can't include the -3. -2.999999, like right after that, no problem, but not -3 itself. And also, we're going to translate this in an interval notation. This interval starts from left to right at -3, and it does not end. The way that we say does not end, or ends at infinity, is with that symbol. We would use parentheses just like our number line, use parentheses always for infinities, and that's it. So we're solving these things like equations. We're making sure our variable's on the left-hand side that will point in the direction that you want to graph, that you have to graph. We're using parentheses because we have no equation part of this. We have no way to say the equals part is in our solution set. And then we're watching out for one thing. If you divide by a negative, you reverse inequality. If you don't, then you don't. What we're going to do is we're going to do just 2 more. I'm going to show you 2 techniques on one, and then we'll just do one more kind of for funsies. Let's take a look at 5 minus 2t is greater than or equal to 10 minus t. That looks a whole lot like some of the linear equations we've been dealing with. It's exactly the same. It just allows more solutions, and there's some caveats to how we treat this. So some special things we got to do. Now, if we were to look at this like a linear equation, which is that's where I want your mind, okay? That's where I want you to really see the technique from. I want you to look at this as, hey, do I have to simplify this side? Well, there's no distribution. There's no combining like terms. There's no fractions. I'm good. Can I simplify this side? No distribution, no combining like terms, no fractions. I'm good. There's no like terms here because these terms are on different sides. No like terms here, no like terms here. Therefore, there are no like terms. Like terms is a side-by-side approach. After that, we get rid of the smaller variable. Now, I just told you, I'm going to show you two ways to do this. Here's way number one, the way that I showed you with linear equations. The smaller variable here, you really want it to be that one? It's not. Negative 2t is the smaller variable. It's the one that's more negative. If you add 2t to both sides, what we do to one side, we have to do to the other. Remember, to get rid of entire terms, we want to get zeros here. That's why we're adding or subtracting to get rid of the smaller variable. We get 5, we get 10 plus t. Negative t plus 2t is plus t. Do I switch or reverse the inequality? No, I didn't divide by a negative. So I keep it the same. Now, some of you notice something right now. You notice where my variable's at. My variable's no longer on the left-hand side of this inequality. What that means is at the very end, we're going to reverse this thing. Now, that's kind of a double-edged sword. So what's good about this technique that I'm giving you, that I've already given you, is that if you get rid of your smaller variable, you won't have to divide by a negative. That means that you won't have to switch your inequality. However, sometimes your variable is going to be on the wrong side. It's not really wrong, but it won't let you draw the number line like I'd like you to. That means that we're going to have to reverse the whole thing anyway. So either way you want to go, it's really fine with me. Just be careful with your inequality. You're going to be switching it at some point in this problem. After that, hey, our variable's here. Let's get rid of the constant. Remember, our variable side drives the problem. We get rid of constants by adding or subtracting. In this case, subtracting 10. We want zeros to get rid of constants. That's negative 5. I don't care about that. I don't care that that's negative. That's just t. 0 plus t is t. I don't care that I got a negative. I didn't divide by a negative. I just subtracted 10. That's okay. Now, last little bit. This is completely the wrong order that I want for you. You can solve the problem this way. You can draw the number line and write the interval notation. I would just prefer that you always stick your variable on the left-hand side. So here's what we're going to do. We're going to take this entire inequality off the board. We're going to flip it. We're going to put it back. Take it off, flip the whole thing around, and put it back. That means that t is going to be over here. Negative 5 is going to be over here. But if I reverse this entire inequality, the entire inequality has to reverse. That's weird. This is another way to switch your inequality. By taking the whole entire problem off the board and reversing it, your inequality also reverses. Now, can you finish it up? Try it if you want to. Try it. Here's negative 5. Now that my variable's on the left-hand side, look at this. Look carefully. If you do it from here, and you go to the right, you're dead wrong. Okay, don't do that. The only time you ever use this as an arrow is when your variable's on the left-hand side. T is less than or equal to negative 5. We use a bracket. That equal says, yes, the value that makes the two sides the same is included. That is negative 5 itself. Our interval starts at negative infinity. It ends at negative 5. I'm going to use a bracket to include that negative 5, just like we learned a lesson ago, or a video ago. We always use parentheses for infinities, always. This is an abbreviated version. This interval starts at negative infinity. From left to right, it ends at negative 5. That's the idea. Now, I'd like to do the same one again. I want to show you a different option. Yeah, we're going to go against the technique I showed you in linear equations. That's okay. I need to show you that they work out the same. So no matter what you do here, it's okay as long as you follow the rules that I'm talking about. Keep your variable on the left, and if you divide by a negative, then you have to reverse your inequality. So let's say that I add t. I'm going to get 5 for sure. Negative 2t, we think negative 2t, plus t is still negative t. We say negative, we write minus. On the right-hand side, we just get 10. We got 10 minus 0, that's just 10. We don't reverse inequality. Now our variable's on the left-hand side. That's great, that's where we want it. You're going to notice why I like this just slightly better because of this reason. If you're going to subtract 5, a lot of students, maybe you're one of them, maybe you've done this before, are going to do this. Because a lot of students really love to just lose negatives. They love that. Not on purpose, it's just easy to do. So if you're going to subtract 5 and use this technique, you make darn sure that you're going to keep the sign in front of your term, because what's that going to do in the last step? We saw this 2 examples ago. In the very last step, what's going to happen here is, well, you're going to have to divide. And you're going to have to divide by -1. You're going to have to do that. Let's say that you forget the negative. You'd think you'd be done. It would end up different than this problem. That's not good. So negative divided by negative is just a +1. On the right-hand side, 5 divided by -1 is -5. But we just divided by a negative. That means that our inequality must reverse. The good news is there are variables on the left-hand side, so this still gives us the direction to graph. In fact, look at, oh my gosh, look at that. It's exactly the same. You can't mess it up if you're following the rules that I've given you. So whether or not you get rid of the smaller variable is up to you. But if you don't get rid of the smaller variable, you are going to be dividing by a negative, so you need to watch out your inequalities. If you didn't get rid of the smaller variable and you're not dividing by a negative and flipping your inequality, you're doing something wrong. Okay, so be mindful of that. Be real careful when you're doing these. It's very easy to kind of mess that thing up. Okay, one more. I would encourage you to pause the video when I put this on the board. Try it yourself. Make sure that you're using brackets and parentheses appropriately. Of course, I'm going to get right to it, but this is like your one guided practice here. Give that a try if you'd like. I want you to look at the problem and think of it as a linear equation. Think about what you would do with it normally. Think about whether this is simplified and this is simplified. Think about whether there's 2 variables or 1 variable. If you don't have 2 variables, there's no way to get rid of the smaller one. So we don't have that option. Think about where your variable is, left side or right side. What that tells you is whether you're going to have to reverse the inequality or not. After that, start seeing what you'd be doing first. Getting rid of a constant, or if you don't have a constant, just divide them. In this case, there's no simplification at all. All we can possibly do is get rid of our constant. Because we're not dividing by a negative, you're not going to flip that inequality. Last step, well, our variable's on the correct side, but I do have to divide by -5. It's huge that we see that. Dividing by -5 just gives us x. On the right-hand side, we get -8. Our signs change. If we divide by negative and our signs are changing here, our inequality also must change. So we subtract 4, cool. Divide by -5. Oh, as soon as you say divide by -5, you're going to reverse that inequality. Divide by negative, reverse inequality. Are you starting to see why I'm telling you that the only time you're flipping the inequality is on the last step? Because that's the only time you ever divide by anything. If you divide by a positive, don't worry about it. If you divide by negative, yes, reverse your inequality. Now, the good news about the problem is that we're set up correctly. Do you see it? Your variable's on the left-hand side. That's awesome. That's exactly what we want. We know that on our number line, we're going to start at -8, and we're going to go to the, let's see, more than 8, more than -8, that's to the right. More than numbers are to the right. The arrow points to the right. I'm going this way. I'm going to be using a bracket to show that I am including the numbers that make the 2 sides equal. That's part of the solution set. We start at -8. We do not end. We use the bracket for -8. We use the parentheses at infinity because we can't actually end there. There is no ending number here. We're just representing this as forever. That's the idea. Practice this before you get started on the next video. We're going to do some slightly more advanced solving. We'll deal with distribution. We'll deal with fractions. We'll deal with decimals. We'll deal with the word problem. So I'll see you in a little while for the next video.